Welcome children. Today we are going to learn how to reduce a rational expression and how to find the excluded value of a rational expression. First, what do you mean by a rational expression? You know that a rational number is of the form p by q. Likewise, a rational expression is of the form p of x by q of x, where p of x and q of x are polynomials and q of x must not be equal to 0. If q of x becomes 0, then we are going to exclude the value where q of x becomes 0. For what value of x q of x becomes 0, those values are considered to be the excluded value for this rational expression. Okay. Now, let us go. I repeat, a rational expression will be of the form p of x by q of x, where q of x is not equal to 0. Keep that in mind, and we are going to reduce a rational expression. How to reduce a rational expression? Yes, as we reduce a fraction, we are going to reduce into lowest form. That is, we are going to cancel the common factors from the numerator and the denominator. If there is a common factor in the numerator and in the denominator, we can cancel it and write the lowest form. If there is no common factors, that is, if the GCD of p of x and q of x is equal to 1, then we say that the rational expression is already in the reduced form. Okay. Now, let us go and do the sums which are given in the exercise 3.4. In the first sum, first the numerator and the denominator should be factorized, and then if there are any common factors, we have to cancel and then we have to reduce the rational expression. See, x square minus 1 is of the form a square minus b square, that is, it is taken as x square minus 1 square. So, we have to split a square minus b square as a minus b into a plus b. So, likewise, x is taken as a and 1 is taken as b here. So, we can split this into x plus 1 into x minus 1 as factors. Yes. Can you factorize this denominator? What is common in the denominator? Yes, x is common. So, we can take out x from both the terms and write as x plus 1. In the numerator and in the denominator, we have x plus 1 as a common factor. So, cancelling those two terms, we will be getting x minus 1 by x. So, this is the reduced form. Next one is, you have to factorize the numerator as sum of the second terms of the binomial. We are factorizing into binomials. A trinomial is given, we are going to factorize as binomial or monomials. So, product of the zeros is 18 and the sum of the zeros is minus 11. Since the product is 18 and the sum is 11, we are going to find two numbers such that their product is 18 and sum is 11. Those numbers are, yes, very good, you have found that they are 9 and 2. So, since the sum is negative, we have to give the negative sign for both the terms. That is, we have to split as x minus 2 into x minus 9. You know the factorization methods in 9th standard. Just recall them and factorize. Okay. See the denominator. So, here the product is 4, product of the second terms is 4 and the sum of the second terms is also 4. It is negative 4. So, what are the two numbers whose product and sum are 4? Yes, very good. 2 and 2 will make 4 and 2 into 2 is also 4. So, as the sum has negative sign, we have to write x minus 2 into x minus 2. So, this is the factorized form of the denominator. So, common factor in the numerator and the denominator can be cancelled and we can write the reduced form as x minus 9 by x minus 2. In the next one, we have to factorize. See, in the numerator, there is a coefficient which is common. So, among 9 and 81, which is the GCD of 9 and 81, that should be taken common. Yes, 9. And in both the terms x is common. So, x can be taken out. So, 9x, here 9x square is there. So, x plus here 81x is there. So, 9 divided by factorize the denominator. See, the denominator is a cubic polynomial. So, we are going to take out x from all these 3 terms. So, x is common. So, take out x and write it as x square plus 8x minus 9. Yes, we have reduced it into a monomial and a trinomial, which is a quadratic polynomial. So, since it is a quadratic polynomial, you know the method of factorization. Yes, first let us write the numerator as such and see, can we split the denominator? Yes. So, this is the product of the terms and this is the sum of the terms. So, what are the terms, what are the numbers whose product is 9 and sum is 8? Yes, since this is negative, we have to say the difference is 8. What are the numbers? Yes, they are 9 and 1. Since the second term has positive sign, the larger number should be given positive. That is, we have to write it as x plus 9 and x minus 1. Among these numerator and the denominator, x is common and one more term is common. Can you make out? Yes, x plus 9 is also common. So, we can cancel x and x plus 9 and write the remaining terms to reduce the expression. So, we have reduced the expression as 9 by x minus 1. Here, since 9 and x minus 1 do not have any common factor other than 1, we can say that this is in the reduced form. Okay. See, the numerator is a quadratic polynomial here, whose product is 40. Since this product has negative sign, we have to say that the difference between the terms should be 3. So, what are the numbers whose product is 40 and difference is 3? Have you found? Very good. 8 and 5. So, 8 should have negative sign and 5 should have positive sign. So, we have to split as the polynomial is in P, we have to reduce as P minus 8 into P plus 5 and reduce the denominator also. Yes, take out what are all common? P is common in both in all the terms and one more term is common. Yes, very good. 2 is also common. So, let us take out 2p and this can be written as p square minus 12p plus 32. Further, we have to split this into binomials, okay, into linear polynomials. Okay. See, I am going to split the denominator as 2p into, so can you split, what is the product? 32. Yes, very good. So, since the product is positive, this should be said as sum. So, what are the numbers whose product is 32 and sum is 12? Very good. 8 and 4. Since the sum has negative sign, we have to give the negative sign to both the terms such as p minus 8 into p minus 4. The numerator remains as p minus 8 into p plus 5. So, what are common in both the numerator and the denominator? Yes, p minus 8 is common. So, striking out, that is cancelling or dividing both numerator and the denominator by p minus 8, we get p plus 5 by 2p into p minus 4. So, this is our reduced form. Can you make out, children? Can you follow me? If you are very much thorough with the factorization, you can do all these sums with very great comfort. Students, a rational expression will be said to be undefined if its denominator is equal to 0. So, let us consider these rational expressions and find the values for which their denominators become 0. Those values should be excluded in expressing this rational expression. While we express a rational expression, we have to say that these values are to be excluded, because if we have those values the expression becomes undefined. So, we are going to find the denominator and see whether for what values of y the denominator remains 0. So, we are going to take the denominators only. We have to check for the values of y for which it becomes 0. So, we have to check, we have to see or equate the denominator as 0. So, equating this to be 0, what values we get? Those are the excluded values. So, we have to factorize this y square minus 25, this expression as y plus 5 into y minus 5 is equal to 0. So, if y plus 5, see a product of two expressions is equal to 0, when will it be equal to 0? Those expressions, that is this expression or this expression may be 0. So, what I say is, if a into b is 0, we can say that either a or b or both will be equal to 0. Can you understand? So, y plus 5 may be equal to 0 or y minus 5 may be equal to 0 or both may be equal to 0. So, the values for which y plus 5 becomes 0 is y is equal to minus 5. So, minus 5 is an excluded value and also plus 5 is an excluded value. So, these are the excluded values for this rational expression. While defining this rational expression, we have to say that we have to exclude, or we should say that y is not equal to 5 or not equal to minus 5. Can you understand? Yes, you could have heard, you could have seen in book, if a denominator is given, that denominator would have been given as that denominator is not equal to 0. So, the reason is here. See this denominator is t square minus 5t plus 6. First, let us factorize the denominator here. So, product of the numbers terms, second terms is 6 and the sum of the second terms is 5. So, you know that 2 and 3. As the sum is negative, we have to give negative sign for both the terms, that is t minus 2 into t minus 3. To make it 0, if we make the denominator as 0, we can say that t minus 2 into t minus 3 is equal to 0. So, these are the values we have to exclude, that is t is equal to 2 should be excluded and t is equal to 3 should be excluded. So, these are the values we exclude. Okay. So, while we write this rational expression, we will be saying that t by, let us write t by t square minus 5x plus 6 is a rational expression where t is not equal to 2, t is not equal to 3. So, these two values should be excluded, that they should be removed. We should not take the values 2 and 3. Can you understand? So, these are the excluded values and see the denominator. So, before that we have to see the numerator also. Numerator is also in the factorizable form, denominator is also in the factorizable form. See, we have to factorize both the numerator and the denominator. Why we have not factorized here? Because they are already monomials, they are already simplified form, but this is not in the simplified form. So, we have to simplify this as, yes, factorize and say, yes, 4 2s are 8. So, x plus 4 into x plus 2 divided by, here factorize, product is 2. Since the product is negative, this is the difference. Coefficient of x here is very good, positive 1. So, the numbers are, yes, 2 and 1. So, x plus 2, that is this sign should be given to the larger number, and x minus 1. So, we can cancel these two. After having the reduced form, we have to go to the excluded value. So, we can reduce by cancelling and we have to arrive at x plus 4 by x minus 1. Now, see the denominator is x minus 1. So, we have to equate this x minus 1 to 0 to find the excluded value. So, x is equal to 1. This is our excluded value. That means, in this rational expression, x should not take the value 1. Okay. See this, here also we have to factorize and then further go to the denominator. See, factorizing, you have to check, yes, this is in the form a cube minus b cube. 27 is written as 3 cube. So, we have to write 27 as 3 cube. So, this is in the form a cube minus b cube. So, you know the formula, just recall the formula. I am going to see the denominator. See, the denominator has, yes, all the terms of the denominator have x in them. So, we can take out x and write as x square plus x minus 6. See this, a cube minus b cube. What is the formula for a cube minus b cube? Very good. That is a minus b. So, x minus 3, a minus b into a square, x square plus ab, a into b, that is x into 3. So, 3x plus b square, b is 3 here. So, b square is 9. In the denominator we have, yes, x into, can you factorize? Yes, the product is 6. Since the product is negative, we have to say that the difference is 1. So, what are the numbers which give 6 as product and their difference should be 1, 2 and 3, very good. So, since the difference is positive, we have to give the positive sign to the larger number. So, that is x plus 3 into x minus 2. See, is there any common factor in the denominator and the numerator? No. So, no factor is common. So, we have to take the full denominator and we have to see if you equate the denominator to 0, what values of x are to be given. Yes. So, we are going to equate the denominator to 0. So, equating the denominator to 0, we have 3 terms in the denominator, all are factored, that is they are in the product form. So, x into x plus 3 into x minus 2 should be equated to 0 to get the excluded values of x. So, we can say that either x is 0 or x plus 3 is 0 or x minus 2 is 0. That means, x is equal to 0 and x is equal to minus 3, x is equal to 2 are the excluded values. These are the excluded values. These are to be excluded to make the rational expression a defined one. If x takes these values, our rational expression becomes undefined. Can you understand why we exclude these values? Let us have some more practice in finding the excluded values. See, this expression has x plus 10 in the numerator and 8x in the denominator. Since this is in the reduced form, we can go to the denominator directly. So, the denominator is 8x. So, if the denominator is 0, we will get the undefined. That is, if the denominator is not equal to 0, we will say that the rational expression is defined one. So, we have to say that when or which possible values of x will give the denominator 0. Since 8x is the denominator, we have to equate it to 0. If we equate 8x to 0, we will get that 8 is not equal to 0, you know very well, it is a constant. So, dividing both sides by 8, we get that x is equal to 0. So, when x is 0, this rational expression is undefined. So, x should not be equal to 0, that is excluded value. What do you mean by excluded value? We have to neglect, we have to leave that value. So, we have to leave the value of x as 0. So, 0 should not be taken as the value of x in this rational expression. And here see, we just have those two factors of the denominator and we are going to equate it to 0. So, while we equate it to 0, we get 8p plus 5 into p plus 1 is 0. That means, either 8p plus 5 is 0 or p plus 1 is equal to 0. If 8p plus 5 is 0, we can say that p is equal to minus 5 by 8. So, p is equal to minus 5 by 8 is an excluded value, and one more value is p plus 1 is equal to 0. That means p is equal to, very good, minus 1. So, p is equal to minus 1 is another excluded value. See this, here the numerator is x and the denominator is x square plus 1. So, see, look at the denominator, x square plus 1. Can you factorize x square plus 1? No, we cannot factorize x square plus 1 in real numbers, because yes, you cannot factorize, but in which form you can factorize? X square minus 1, you know, do not confuse it with x square minus 1, this is x square plus 1. Any value, that is any binomial which is of the form x square plus a, where a is positive, is not factorizable. So, this is not factorizable, and we can equate this denominator to 0 directly. So, we get as x square is equal to minus 1. Where will we get x square is equal to minus 1? In real numbers, we do not have any number whose square is negative, no excluded value. This is always not equal to 1, and always x square plus 1 is not equal to 0. So, since it is already in the form where we cannot say that the denominator is 0, that is, here the denominator will never become 0 for any real value of x. That means, yes, there is no value which is said to be excluded for this rational expression. Any rational expression whose q of x is 0, then we will say that it is undefined, the rational expression is undefined. Since q of x will never become 0 here, we will say that this rational expression is already in the defined form for any value of x. Can you understand, students? For simplification of rational expressions, we need to know the factorization. So, let us recall the factorization of these expressions, for which will be useful for your next exercise also. This will be useful for this exercise also. Let us recall whatever we have learnt in 9th standard. See, we have a quadratic polynomial, that is a trinomial. See, the last term is the product of the numbers, that is product of the second terms of the binomials, where we are going to split. That is, we have to split this into two binomials, product of two binomials. So, the product is 21. So, we need to find the numbers whose product is 21, and since it is positive, we have to say that this is the sum of the numbers. So, we have to search for the numbers whose sum is 10. Since the sign is 10 minus here, we should say that those two numbers will have negative sign. Okay. So, what two numbers? Yes, have you thought? Yes, very good, 7 and 3. So, 7 and 3 are the two numbers whose product is 21 and sum is 10. Since the sum is minus 10, we should take both the numbers as a negative. If the product is positive, the numbers will have the same sign, whether they are positive or negative. So, we have to split it as x minus 7 into x minus 3. Okay. See the next one, the product is negative. If the product is negative, we have to say that we have to think the sum as difference of numbers. Here the coefficient of x is 1 and the product is 12. Yes, what two numbers are in multiplication give 12 and in addition give 1. So, 12 is the product and 1 is the difference, think of difference. So, they are 3 and 4. Okay. 4 and 3 are the numbers. We have to give the larger number the sign of the coefficient of x. Yes. So, this is plus and this is minus. So, on inspection you could have told this x plus 4 into x minus 3 are the factors of this trinomial. See this trinomial, and here the coefficient of x square is 1, but here the coefficient of x square is 2. So, product of the numbers is product of 2 and minus 20, that is product is minus 40. Since the product is negative, we have to think that this 3 sum is the difference between the numbers. So, here the sum is written as 3, but you have to think that the numbers differ by 3. So, what are the numbers? Very good, 8 and 5. Since the sum is positive, we have to say that the larger number should have positive sign. See, we are going to split this middle term using the product and sum. So, sum is 3. So, we have found that the numbers are 8 and 5. Since the larger number should be positive, 8 is positive and 5 is negative. So, we are going to split this 3x as plus 8x minus 5x, and the third term is written here as 20, okay, minus 20. So, you know the middle term is split into 2 terms. So, you know grouping method. So, we are going to group these two, okay, like, so from the first 2 terms we can take out, very good, 2x as a common factor. So, x plus 4, here minus 5 can be taken out, and here also x plus 4 remains. Since these 2 terms have x plus 4 in common, x plus 4 can be taken out, and here x plus 4 is multiplied. We use the distributive property, okay. Think of the distributive property. We have taken out x plus 4 and we have factorized finally. See, x square has a coefficient 3. So, the product of the numbers are 3 into 6, that is 18. So, product is 18 and the sum is 9. What 2 numbers? Very good, 6 and 3, very good. So, we are going to split the middle term as 6xy plus 3xy, and the first and the third terms remain as 6y square and 3x square. So, you have to use the grouping and factorize. Can you do this? If you practice factorization a lot, you will be finding it very easy to simplify a fraction or simplify a rational expression, okay. So, try these sums and do these as homework, okay. Let us meet in the next session with new number of problems. Thank you, children.